In this lecture, I'm going to talk about dynamic binding. Dynamic binding is one of the important topics in polymorphism. Let's review the topics in polymorphism. Polymorphism has compile time polymorphism and runtime polymorphism. We have compared the overloading and the overriding in the previous lecture. Right here, we will be focused on how to implement the overriding for virtual function for runtime polymorphism. First, let's look at the method signature matching. If you are using the Eclipse editor that comes with the information extracting, of course this takes more time and the Eclipse is much bigger than Bootj. But if you have that editor or the NetBeans, they will provide the available sorting methods listing when you just type sort. That requires information extracting from your compiler environment. As you can see right here, it has already been listed down the package that you imported for your program for arrays. Say, arrays have several sorting algorithms, and each one has different parameters. The compiler matches the method with different signature when you do compilation. And this matching work depends on the scope, visibility. If a method is called based on where the method is located, and the method signature matching decides which method to use. And this is for the overloading. And for overriding, since the method signature are the same for two different classes, so it will depend on the dynamic binding. And this method signature matching provides a matching for overloading and overriding, but overriding are sharing the same signature. Method matching vs binding. Matching the method signature and binding the method implementation are two different issues. Matching the method signature is to check the compatibility of a function, and binding the method is to find the execution call for your method. The compiler finds a matching method according to parameter type, a number of parameters, and the order of the parameters at the compile time. A method binding may be implemented in several subclasses. The Java virtual machine dynamically binds the implementation of the method at the runtime. Here, let me show the idea of dynamic binding. For example, right here we have class binding. We have two pointers of the A type, and each one create an object using different constructor. One using the A class constructor. The other use the B class constructor. And because A is the superclass, so both of the pointer in A class pointer is okay to accept the object from A class and B class. But however, when these two objects find the method, they are finding different body of the method from different class. That we call it dynamic binding. And at the compile time, they match the method, it's okay. They just match the header of the method. We call it signature. But when they are executed, they need to find the body of the method stored in the method area of the memory, and they will find different copy of the method. For static binding, it's different, done at the compile time. A static binding is like you have a pointer pointing to a certain object, and that address for the method x.area already been determined at the compile time. We call it static binding. So binding has two different ways, static and the dynamic. Static is done in compile time. Dynamic is done at the runtime. Right here, let me show you the polymorphism and the relationship between dynamic binding and the generic programming. These are very useful for .class file, Java bytecode, or .dll, C++. Right here, as you can see, it's a polymorphism demo program. You have a main function, make 4 different method code coming with different pointer generated with 4 different constructors. And these constructors are of the same class hierarchy. The top level is object, and then it is the person, and then it's student, After that is graduate student. So right here, the object has a toString method, and the person also has a toString method. Method M taking in different input reference pointers. All of them are in the class hierarchy of the object type. You can invoke it with any object. So basically, because M taking in object type, an object is the top level for the whole class hierarchy of any user-defined class in Java language. So basically, any pointer or any constructor can be put in here as a parameter. And as you can see right here, an object of a subtype can be used wherever its supertype value is required. This feature is known as polymorphism. When the method M object X is executed, the argument X toString method is invoked. X may be an instance of graduate student, person, or object. Class graduate student, person, and object have their own implementation of the toString method. Which implementation is used will be determined dynamically by the Java virtual machine at runtime. This capability is known as dynamic binding. So, when we talk about a polymorphism, it's about one pointer type accepting different pointer of the subclasses. And then to resolve the method calling when a certain method is called for a different pointer to the object of the subclasses. It is resolved by dynamic binding by Java virtual machine. So dynamic binding is a way to support polymorphism by linking the method to the right class type. Let's go for Blue.js to take a look for this dynamic binding demo.java. Right here, we have this class dynamic binding demo.java. It is actually the same code with the polymorphism demo.java shown in the slides. And then right here, as you can see, the top level class is object. And then the next level is person, and then is student, and then graduate student. Each one has different toString method, except for the graduate student. And graduate student will use the version in student class. And when this program gets started, it creates an object of graduate student type for object O. So this O is actually graduate student type. And then we new an object in object class for O1. And then we check if O1 is an instance of the graduate student. In fact, it is not. It is a superclass of the graduate student, not subclass. So never got here. Even if it got here, we will try to custom it to the graduate student pointer type. But anyway, this is not important. We get into here, we use parameter of 4 different pointer type and then run it. Each one go into there. For the graduate student should be using the student. For student should be also using the student toString method. Person will be using person. And then the object type pointer will be using the default toString method by object. Let's run it. So right here, as you can see, the graduate student type will be using the student toString method that will be printing out student. And then the student class also print out student. Person will get the person string and print out. Object has no overriding method, so you will be using the default method for toString. That will be printing out the class name at the hash code. And the hash code is the memory address of the object. So this program clearly shows you how dynamic binding works to find different methods of the same name for different subclasses under one class hierarchy. So for dynamic binding, we may have a sequence of classes. For object O of the instant class, C1, C2 to Cn. Say right here C1 is just like graduate student. Cn is the object class. And then we will have a whole list of different classes. And because of the inheritance hierarchy, we will be checking the toString method through this list, starting from C1, that would be graduate student, to Cn, that would be the object type. If there is a toString method, we will use it in the C1 class. If not, we will check C2. And if there is a toString method, we will be using C2. If not, we will keep moving on to there. So dynamic binding, when they try to bind the methods for a certain object, it will be checking from the leaf class up to the top level class. And this is the way that dynamic binding is done. So as I mentioned before, the subclasses is just like a wrapper class. It adds more data, fields, and methods to create a new class based on the inner superclass. So C1, for example, just like the graduate student case, it is the outer layer of the wrapper class. And then the second one, student, is inner. And the top level object is the most inner class. And then when we try to do dynamic binding, we move on from outside, get into the inside. So the inside method will be the last one being used, only if the outer layers doesn't have the same method. Generic programming. Polymorphism allows methods to be used generically for a wide range of object arguments. This is known as generic programming. The way we call it generic programming is these four objects all have toString method. So we actually have a generic name called toString that apply to every classes in the same class hierarchy. So for different objects, we all have toString. We all have equals method. You can create different kind of the methods using the same name, like .clone, like .copy, or any method you want to have. If a method's parameter type is a superclass, you may pass an object to this method of any of the parameters subclasses, say student or graduate student, something like that. When an object, for example, student object or the string object is used in the method, the particular implementation of the method of the object that is invoked is determined dynamically. So polymorphism is about mixing different objects of different classes. When we try to bind the methods, we need the dynamic binding. And then we define the methods, we need to have the overriding feature. And then the end result, with the dynamic binding and the overriding, we provide a programming concept called generic programming. Thank you. Bye.